9 minit.
Ya, kay labor.
voice, and then also board and laptop, all clear? So I'll just write something here so that you can make out. Even display also should be clear. Display also. Voice display. Sometimes what happens is, people go for lesser data. You have to at least go to 480. Remember, if you don't go to 480, it will not be clear. When it is 480, it will be crystal clear then. See. Now, all clear. Laptop, no problem. Charging also on today. And I told you last time I told you one thing, you forgot it. One comment always make in the beginning. See, you forgot it. Yesterday I told, whoever comes first, see, even if the live is not on, when you enter there, you will be waiting. But comments you can write. I told last time, without forgetting that call block. I told last time, call block. See, you are not given comment today. At least give that comment so that when I see, in case call block is not done, I will block the calls. Otherwise, what happens is, halfway through, in case a call comes and screen gets inverted, then I had once again reschedule it. It will take 10 minutes more. Last time I told, good evening, someone. So remember, just call block charging. Other things I am asking here only. Okay, now start. See, we are entering the most powerful part of RC structure, that is footing. See, footing or foundation. Footing or foundation. Remember, footing or foundation regarding pressure variation and the principle of pressure variation when axial load is there. When you got axial load with this moment acting this way or this way, either uniaxial or biaxial, they all to be discussed with the basic principles. But that is required only for pure RCC batch. Pure RCC batch it is required. Yes, for the pure RCC batch, everything discussed. I told about if bending comes this way, see, for the force here, this is the contact area. Area is L1 into L2. And if BM comes this way, then axis comes here, then bending stress will come, for which the plan is the cross section, BD square by 6 section modulus, side parallel to axis width and other is depth, or if moment is acting this way, which dimension is along that one is the depth. These all told, and also SBC, how to get from UBC, everything is told. I think in the RCC batch, I continued up to punching, yes or no? I continued up to punching there, correct? Those who came to RCC, I explained up to punching there, if I remember. That punching part I explained last class. Last when I stopped there, little pending I told I will continue now. I think those who are coming for RCC, I think the punching part I told. So remember, and this, therefore, I don't have to worry too much about unnecessary theory here. This is class for ETAPS and SAFE. So that minimum, not minimum, required principle is given. So there's extra principles I told earlier, even footing, the pressure variation, self-weight, etc., everything told. So that I will not tell here, but I will tell the concept here. See, first, remember, when a column is, I won't write there. See, we got a column. If you place the column directly on soil, what will happen? The contact area of the column will be, the cross section of the column will be in contact with the soil. Then, how much pressure comes, how much stress is acting on the column? Same stress will act or pressure will be there on soil. Concrete is very stronger. Soil is very weaker. See, suppose you take M20 concrete. Direct compression. Stress allowed is how much? 0.45 FCK. Your 0.45 FCK, actually that is the factored value. So working load corresponding divided by 0.15. Sorry, divided by 1.5. Therefore, divided by 1.5. So FCK is 20. So 0.45 into 20 by 1.5. 6 Newton per mm square. So it will be a stress of 6 Newton per mm square. If it is only axial load, this much stress will be there in concrete. Of course, I ignored the steel also. Okay, imagine steel is not participating. Now, if you place the column directly on soil for that much contact area, soil will get a stress of same 6 Newton per mm square pressure. Now, safe bearing capacity of soil is imagine around 200 kN per meter square. This is the bearing capacity of soil. So someone will tell, sir, no problem, safe. Why? Stress of 6 Newton per mm square is coming, whereas limit is 200. No, that is 200 kN per meter square. This is 6 Newton per mm square. So if you convert this 6 Newton per mm square to kN per meter square, the stress in the concrete will be how much? 6 divided by 1000 into 1000 square will be 6000 kilonewton per meter square. So 6 Newton per mm square stress on concrete is actually 6000 kN per meter square. Now, therefore, soil will get a stress of pressure of 6000 kN per meter square. It can take only 200, so it will yield and the column will pierce to the soil. This much common sense required. Therefore, what you are doing, the column load which is acting on a smaller cross-section area is to be spread on larger area. So, if you see the plan, see, I am writing the plan here now. Plan means what? I don't have to write here column, what you can see in the front view, side view. If that much you are not knowing, not fit for learning. So, if I take cross-section, see, this is the column cross-section. And I will take as usual, one side S1, other side S2. Now, this is the footing plan. It's a footing plan. Or, in case I put front view, how it will come? Column will come this way, see, footing will come this way. So, this is one dimension. The column load is here. Here, if you show column load, remember, it is perpendicular to the plan. Okay, now, I will take this as L1 and this as L2. Remember, I am restricting my explanation for ETAB and safe batch. Of course, it will be injustice for RCC. No, this all I told in RCC class. So that problem is solved. Otherwise, I have to take separate class. Why? How much I explain for ETAB and safe class there, how much I explain RCC, you know it in the beginning all. Therefore, it is injustice. But luckily, that part already told you. So when it comes to after punching shear, if requirement is there, I will give more information. So see now, column load is like this. Therefore, this is, see, when you apply load this way, the contact area of the footing with the soil, see I write here now, contact area of footing with soil equal to L1 by L2. That is L1 by L2 is the contact area. See, load is applied like this. Therefore, what is pressure on soil? Pressure on soil equal to column load, that I will take P, not over, plus, tell me, column load is P, not over, plus what is there? P is the column load. How much load from column is transferred? But when you go to footing, extra weight will come. See, soil filling will be there above self. I want to ask you, I am only telling the answer. So therefore, what is next? What is next? When it comes to soil, what is the other load? Bending moment. When you go to soil, when you consider soil, the load coming is not only column load plus what? Plus bending moment. What is bending moment all coming here? When you consider the soil, the load transferred there is not only column load plus weight of soil filling and also plus also most important self weight of footing, which is very heavy, plus self weight of footing. Now The self weight of footing along with some soil filling will be there. That's all is approximately taken as, anybody can tell what percent of the column load? Approximately taken as what percent of the column load? Approximately. Because in the beginning, till you know the footing dimensions, you can't find self weight. So universally accepted as 10% of column load P. Therefore, finally load on soil equal to P plus 0.1 P, 10% equal to 1.1 P. So 1.1 P is considered as the load transferred to soil. Now, therefore, anybody can tell if that is the load transferred to soil, what is the upward pressure? What is the upward pressure? Upward pressure from soil to footing. Upward pressure from soil to footing means this way. Upward pressure. See here. Load is P, extra 0.1 P, total is 1.1 P equal to 1.1 P divided by what? Contact area. Contact area, remember, contact area is always area in plan. Area in plan, that is equal to L1 by L2. This is the pressure and this will be uniform pressure. Uniform. Remember, upward pressure is considered uniform only when the column is transferring what? When you connect the column with the footing, there should be only what? Pressure will be uniform if there is only what? From the column to footing, what comes? Pressure is uniform if there is only what? Common sense. See, you take a wooden plank, place on a soil, rough, weak soil. If you stand randomly somewhere, where you stand will sink more. Other side, if you stand too edge, other side will get lifted. But one particular point, if you stand, no lifting possible, it will press the soil almost uniformly. Which point, tell me? Which point? One particular, see in the boat all, when problem, where people want, see in the boat all, they always tell so that resultant load on the boat will somehow pass where? Through CG of the boat contact area. Have you seen? If too many people go to one side, that other side will get lifted. So therefore, resultant load should come to CG of the footing. That is possible only if the column load P is only axial. Okay, now, but practically, see, only axial, I can't show it here. I cannot show it here this way. See, this way, only axial. But practically, only axial load will not come. Or some rare, that is possible once again, if the column is placed exactly symmetrical on the footing. That is equal offset here, equal offset here. Some rare cases, due to some problem, maybe this offset is little more, this is lesser because of boundary problem. Not too much, little change. Then the load will become eccentric. When the load is eccentric, then what happens now? Then additional stresses will come, given by M by Z. Proof I don't have to tell, M by Z. It will compress on one side and lift on the other side. So it is actually plus or minus M by Z. If the moment is only in one direction. Suppose moment this way is there and also this way is there, it will become M1 by Z1 plus or minus M2 by Z2. Therefore, remember, make a note. I write a note here. See. Make a note first. First a note. See, if in case of pure axial load, upward upward pressure equal to, this is called gross pressure, remember. This upward pressure we are calculating, accounting for weight of footing, is called gross pressure. Reason I told in RCC class. Very clearly I distinguished between gross pressure and net pressure. When you find the area, when you find the planned dimension of footing, you have to consider gross pressure by actual pressure. But later, when you find the bending moment and shearing force for the footing slab cross section this way, at that time you have to consider net pressure. In net pressure, weight of footing is not considered. So many people know it. They study in RCC. Someone will tell them, see, when you find the area required, you consider 1.1 P, 10% more. And that pressure is called gross pressure. But later, after finalizing the footing dimensions, when you ensure that pressure is within the limit of bearing capacity of soil, when you go to further steps, then you should not consider gross pressure, you should consider net pressure. When you consider net pressure, see, gross pressure is 1.1 P by A. Net pressure is only P by A. The 10% is not considered. Almost everybody know it in BE. So many books you can see statement. What? First gross pressure, next net pressure. But I am so sure more than 90% are not knowing the reason. For gross pressure, sir, we take 1.1 P. For net pressure, you take only P. 1.1 is not there. Both are pressures. Why? Later, weight of footing is not acting. It is acting. It is acting, still not considered. It has got reason. In the RCC class, I told the reason. Remember it? Yes or no? Tell me. RCC class, I told the reason with an example. When it finally gives same answer. If you remember, RCC class, I told the reason with the example. Tell me yes or no. If you remember, I told the reason in RCC class. Crystal clear reason. I took some member here. I considered self weight. Then column load, pressure, first the gross pressure. Finally, when you account for that one balances, net pressure will cause SF and BM. Why no answer? RCC class I told very clearly, I know it. I told that same day, make a note. But these classes all, that way discussion is not possible. If I discuss that way, another 6 months, I can take RCC part only. No, I want to finish earliest possible. Because this is structural knowledge. This extra knowledge you should learn by respective subject. So remember, when you want net pressure, it is only P by A. Okay. Now, this gross pressure, whatever I told, should not exceed what value? Tell me. For safety, the gross pressure should not exceed what? The gross pressure on soil, including considering weight of footing, etc., should not exceed. The gross pressure should not exceed. For safety, we want soil to be safe. We do not want to overburden the soil. So the should not exceed SBC of soil. Should be this term, now I'll put here now, should not exceed SBC of soil. Therefore, what you can do is, you take A that side, 1.1 P divided by what? SBC of soil should be either more than or equal to area, contact area, area in plan. Or if you read from this side, area in plan, what you are going to provide should not be from that side less than 1.1 P by SBC, or common language. 1.1 P by SBC of soil will give area required, so that pressure is exactly equal to SBC. When you provide, when you provide the area, you should provide either equal to that area or little more. Suppose you provide little more area, pressure will come down, safe. But if you reduce the area, pressure increases. Therefore, 1.1 P by SBC of soil is called area required in plan. That is the minimum area required. Okay, now this is when you consider what? Only axial load. Now make one more note. Suppose there is not only axial load P, also bending M1, bending moment, and M2 this way, uniaxial or biaxial. Then the pressure is not 1.1 P by A. You write now, later I am going there. It is 1.1 P by A plus or minus, the pressure will be 1.1 P by A plus or minus M1 by Z1 plus or minus M2 by Z2. Then pressure will not be uniform. It will vary along the length and width of the footing. Then somewhere pressure will be maximum. Somewhere pressure will be maximum. It will be at a corner. That maximum pressure should not exceed SPC of soil. And other one more corner, actually opposite corner, pressure will be minimum. See now, this will try to compress the soil. Other corner, this M1 and M2 will try to, one corner load will compress, M1 will compress, M2 also will compress. That is highly stressed part. Opposite corner, load will compress, M1 will lift, M2 also will lift. Lifting is not allowed. Therefore, anybody can tell the minimum pressure should not be what? Minimum pressure should not be what you can tell. We want everywhere soil to be compressed. Lifting is not possible. So remember, these all I told in RCC class for you, easy language. When you calculate the pressure, minimum pressure should not be negative. That's all. Minimum pressure should not be negative. Should not be negative. Negative pressure means there is lifting. That's all for this batch. Further I can't tell, because if I talk further more, I cannot finish the structural part. I had to go to software earlier as possible. I have got a scheme now. According to the scheme, I had to go to software part. Because so, but minimum requirement, knowledge is required. Therefore, remember, maximum pressure should not exceed SPC of soil, and minimum pressure should not be negative. We want that also to be positive. That means one side highly stressed, one side lesser stressed. Stability also comes then. That is, lifting is not allowed. All these checks are for gross pressure. But once you conclude or once you finish footing dimension finalized, then for any further calculation, you should not consider gross pressure, you should consider net pressure. When you find net pressure, it is not 1.1 P, it is only P. The 10% is not there. Reason told for you convincingly in RCC class. Others, think. You think and get the answer. Otherwise, believe me, you should, if you are not able to get the answer, you should tell finally, what? I am not understanding properly what is the concept, but that all comes in basic subject. The structural part in the software classes, this much no one will tell you. So this is beyond the limit. So that you think. Or finally, suppose you are not able to understand, you write a note there. Because restrictions are the limitation, time factor is there. It is not, our course is not RCC course. He is giving structural knowledge and we somehow believe him, therefore nothing to do, we will believe him. Okay, believe me. And write one more, he can be believed. Or you should take a challenge. Okay, let me start thinking now. Let me start thinking and get the reason. Ask somewhere. There are experts are there. You ask anywhere, you will get the idea then. Okay, now, second point, remember, you consider only axial load. See, now, consider only axial load. Remember, this is the very, very important for your, right here, what I am going to write now is, I will use red color. Why? Now, what I am going to write is very, very important for footing design Using what? Tell me, anybody can tell? Very, very important for footing design, using, not manual. For footing design, using. Which one? What I am telling now is very, very important for footing design, using what? You know what? Later. For footing design, using. This is much difficulty to understand. Using Excel. This is not Excel class. What is this? Is it Excel? I am taking Excel class here. Is it save? Footing design, E-tabs and save. Using save. Oh, save should be red color. Okay, no problem. Identify. Using save. Save means save, E-tabs and save. Remember, you write a note here. Note. At that time, when you design, it is not only P. M1, M2 will also be there. Nothing to worry. I am there. What we will do is, we will first ignore M1, M2. So first we will consider only axial load. And for only axial load, we will do some calculation. Then, considering the additional pressure due to M1 and M2, here M1, M2, but later our M1 is M3, our M2 is M2. I don't remember now. Okay, that you don't bother. No. Our M1 is MY, and our M2 is, this is MY, M2 is MX most probably. Yes, I will tell at that time, don't worry. Why should you bother now? That is global coordinates there. That all don't bother now. For us, M1, M2. Okay, now see. At that time, we will first ignore M1, M2. So what I am going to tell now, we will do it that way and fix the value of L1 and L2. Because when you go to prepare a design by SAFE, what you do is, first you mark the contact point of all the columns in the SAFE. SAFE plain page, full empty. You transfer all the contact points. Import it from E-tab. Remember, that contact point is nothing but where in the E-tab building frame, the support fixed end is there. Base. You transfer to SAFE by importing. Then, but you also import not only what? That point, also import P, M1, M2. How? It will be told in the E-tab class. Import. So, in the SAFE X sheet, in the SAFE model, you get the contact point with load and biaxial bending will come. Then, immediately that point, you have to provide the footing slab. See, this way. How to provide? Very simple. Mark a point, spread here. See, move, press the cursor and move. Suddenly you get this way. That all comes in the SAFE E-tab part. Now, you should know how much, imagine 3 meter and 2.5 meter. How to get it? If you make randomly, then there is no guarantee it is safe or not, and economic counts. So, to get this 3 meter and 2 meter, 0.5 meter, there, what you have to do is, you have to use some principle I am going to give now. So, suddenly now remember, we are in the SAFE part. Suddenly we are doing something which is required for SAFE. And what we can do is, some calculations are there. When you do a building project, there is no time for calculation. Therefore, what you are going to do now to fix, one of them is called L1, other is called L2. When you are fixing L1, L2 later in SAFE, what we can do is, tell me now. What you can do is, side by side, we will have what? Tell me. Side by side, we will have. Side by side, we will have. This you know it. Software, side by side, we will have a. Side by side, we will have. Think a little. Side by side, we will have some idea. Side by side, this much difficulty, you know it. Software correct, side by side. Oh, what is this? Manual, you are not understanding. Side by side, you know the answer. Side by side. We will have a Excel. We will have Excel. I will tell you preparation of that Excel here. It comes down. We will have Excel. And remember, when you design the foundation in SAFE, they will have not one Excel, you will have two Excel sheets. First Excel sheet heading will be to fix L1, L2. That's all. Then what you have to do is, actually so many places what happens is, judgment will do. Sometimes people decide and roughly by judgment. Okay. But critical cases, one Excel to get L1, L2. Parallelly, one more Excel is there, because when you design the footing slab by SAFE, punching shear check Excel will do, sorry, E-tab will do. E-tab or SAFE, software will do. Right? Pressure check, software will do. Pressure check, software will do. Then bending moment shear force, software will do. And also reinforcement required, software will do. But punching shear check, software will do. One number will come. That number should not be more than 1, because that I'll tell you later when you go to software. That number is actual stress by allowed stress. Actual stress by allowed stress. It gives a number. If you right click there, it will tell you peri of the critical section, what is the punching shear force, what is the resisting area, what all you do in the class today, SAFE will show if you right click. Nobody want right click there. No time. So, but one thing, in case of footing, like I told earlier, in ordinary floor slabs, we don't consider shear for slab. Remember, in ordinary floor slab, I told earlier, shear, leave it. Remember or not? I told earlier, floor slab shear check. Who is going to do it? Nobody will do check for shear for floor slabs. Remember, even we checked it. It was so safe, we decided and leave it next time onwards. Yes, but remember, when you go to footing slab, there the most critical, number one troublemaker is shear. Shear. Shear is very critical for footing slab. And remember, not one type of shear, two types of shear. One of them is called one-way shear, other is called two-way shear, or one of them is called wide beam shear, or your shear which will cause diagonal tension. Second one is called punching shear. Remember, both the shear are very critical. Actually, in case of footing, the main deciding factor is shear. Now, punching shear, you don't have to bother. Actually, here you will bother. You don't have to bother because your software will take care of it. But the software programmer, he has not given for other shear. That is, the shear creating diagonal tension. That is what? Like this way. See? This diagonal tension crack. That shear, they are not accounted. Maybe they decided, let the designer do it. Free everything should not be done. If I give everything, then people will design very fast. No. Let them design or have an Excel. So you will have two Excels. One Excel for today's important to fix L1, L2. Other Excel is to check for shear. If you got the Excel sheet, what you have to do is very simple. When you want design L1, L2, all you require is see the result there, type P, type M1, type M2, over. It will tell you L1, L2. And when you want check for other shear, that important shear, all you have to do is simply in the Excel, move to critical section there, see the shear post reading, type the shear and type the steel provided, that's all. It will tell you safe or not. But those who are experienced, they can Excel sheet, I will tell you at that time to extend further. Someone will prepare Excel sheet. Already see last time for biaxial bending, Excel sheet. In the YouTube I have not told, reason, no response. But now I decided to continue to because I got some 3-4 requests there. One person even called me also. He told, sir, please continue YouTube. I told, continue, correct. Have you shown responsibility? Or what I told, you should come live. They are not come live. All are going for record version. That is later. See, I told them, see, what happens is, imagine you are giving food, open, charity food. This is food. This is like charity only I am doing in YouTube. You should not ask for parcel. The one who is giving food, he will be happy if he serves the food and he will see the people eating it in front of him. That is, you should come live. Then I will be happy. Oh, people are using it. You cannot go to there and tell, oh, you will food, Kannada, Anna Santarpane. Sumne, free agi. You should not ask for parcel there. You will tell, no, I want parcel. Parcel service should not be there. That you should think. See, when I see people responding here and in good number, it gives motivation. Still people don't understand. They will see later. See, all RCC classes, so many are watching. But when parcel, you should leave that habit at least. But he is going for a good cause. So I decided to continue for a few more classes. I will see them. This class over, next class. Then when I go to critical part, column with axial load and biaxial bending, then I will announce tomorrow, not YouTube. That is final. Because what I will do is, the most critical part, I will hold back. If I get good response, continue. So it is your choice now. Okay. Further I won't tell. Okay. Video blur. Video blur. Someone commented. Video is blur. Is the video blur? I don't think video is blur, I think. Someone commented, just check it. 4.8. Okay. No. Little blur it is. Okay. 1 minute. Okay. That is because of what reason? 1 minute. Now, okay now. Now okay. Because now okay. Actually, when I record for YouTube classes there is a camera called open camera. There is a setting where exposure can be locked. Now okay. Okay. Anyway, if any problem is there, let me know immediately. I will see the comment there. Okay, start. Now, first consider important now. See, put a heading here. Later I will ask here, at least 2 people. I know. One of them is Mr. Nandakumar, other is Tushar, who will prepare Excel sheet. Now see, for column design with axial load and biaxial bending, Excel sheets are already given for you. I explained last Sunday, second half, not in YouTube, in your Zoom app. And in the group, it is distributed. They sent in the group. Did you receive it? Mr. Tushar, yesterday, he published there in the group. Still blur. Okay, I will see. Okay, did you get it? Excel sheets for column design. It is sent in the group there, respective group. RCC and the CTAP group, it is sent already. Okay. Is still blur? 1 minute. Why problem? 18.9. I'll check once again. Still blur means I have to do something. No, it is not blur now. It is clear. It is not blur. It is not blur. Someone told still blur. Okay now? Clear. Okay. Anyway, I will see the comments. Now see. Make a note. You write here first. Important. See. How to decide L1 and L2, L1 and L2 when L2 considering only axial load. Only axial load. Remember, this is not for your Excel sheet. Excel sheet I will modify. I will tell there how to decide L1, L2 for software design. I will give that Excel for you. Remember, but on that Excel, same principle is used. How to decide L1, L2 considering only axial load. So now I won't prepare Excel now. I will give example now. Later, when I consider P with the M1 and M2, that I will go for Excel sheet. That somebody will prepare and send you. Okay, start. 1 minute now. See, this is the plan. We are considering the case when column is placed centrally through the foundation. By chance, if it is placed slightly eccentric, separate principle I will tell you in the software class. This class I will not tell because usually everywhere it is placed centrally. See now, this is your L1, lengthwise dimension. This is your L2. Remember, this is the plan. That much common sense required. Your axial load is here P. This is your S1. This is your S2. Column dimension S1, S2 and footing plan dimension L1, L2. Load is P and most important, P is axial load. And one more important, we are going to consider SBC of soil. When you are considering SBC of soil, tell me it corresponds to working load or factored load. Very important. These all you should know. When you go for, when you consider SBC, again blur. What is the problem today? Why? There is no net, no blur. Everything is clear. You are not using 480, I think. Most probably you are not using 480. It is so crystal clear. I can see in the other mobile. If it is blur for everybody. No, you are not using 480. You are using or 144 most probably. Most probably you are using 144 or 240. Go to 480. It is not blur. It is crystal clear. No, so crystal clear. Yes, you are not using 480. That is the only chance. You are not using 480. It is so crystal clear. I can see here because it can't be blur for me and blur for you. Use 480. That much data you have to sacrifice. If you use 480, maybe around 1 GB for 2 hours. Okay. If you want to learn, if you are willing to sacrifice that much data, can't expect that also I want 144 like that. Okay. Anyway, if blur is there, let me know. It has never happened so far. I will think of alternative for that one. 1 minute. Okay. Okay. Now, see, axial load. Tell the answer. When you consider SBC, means safe bearing capacity. That is how much pressure is allowed on the soil. That is actually ultimate bearing capacity divided by factor of safety decided by soil testing. Not your problem. Structural engineer, when he goes for design, he will get information for SBC. So tell me, SBC is for working load or factored load. The SBC corresponds to working load or factored load. Answer. SBC means it corresponds to working load or factored load. Answer fast. At least something, idea. Every point I am telling you have to make a note. Don't listen today, tomorrow forget. It corresponds to working load. So remember, when you fix the footing dimensions, your P means very important. It should be working load. I will not tell second time. I will tell only once. Even if you design by limit state method, it is pressure, whenever you do something for pressure, consider the pressure, then P should be working load. Remember. But later, what pressure you get, that pressure right here. So when you consider working load, you get the pressure corresponding to working load. Now, when you go for design later for punching or one-way shear or two-way shear or bending, etc., what all you are getting is corresponding to working load. At that time, what we will do? We will get the factored values by multiplying by 1.5. So when you use the pressure, it is always working load considered, and any calculation, whether shear force or bending moment you are getting, is corresponding to working load. So in the design, you have to factor it. But software, no problem. Why? Software will take care of it. See, software it will not ask you about these things. It will pressure check, it will do for working load, and bending moment it will do for factored load. You don't have to worry. This is for manual design. Okay, remember now. Working load to be considered. Tomorrow, be careful, don't make mistake. If you should consider working load here. Okay, over. Now, see. First find, I'll write here now. See. First find area required. Area required in plan equal to 1.1 P divided by SBC of soil. In the bracket write, I am not writing, you should write. Assuming weight of footing along with some other weight as 10% of column load P. So get the area required. This area required is area required in contact area, plan. This area required, remember, is equal to and equated to L1 by L2. Equated to L1 by L2. Okay. Therefore, I will call equation number 1. Equated to L1 by L2. So, now you know the value of L1 by L2 equal to answer. Make a note. This is the required area. If you want, you can provide little more, no problem. Less you should not give. Okay, now, next point. There are two unknowns are here. So what to do is, next, how to decide. See, you know the value of L1 into L2. How to decide L1 and L2? I will not tell the procedure if the footing is a square footing. Tell the answer. If it is not clear, right now leave my class. Suppose you are going for a square footing, then how to get L1, L2? Tell the answer. If not clear, right now leave the class. Tell what to do. Whatever area required is there, what do you have to do? No. If it is a square footing, usually footing will not be square. What do you have to do? Whatever area required is there, what do you have to do? Tell me. Take square root. Square root, you get the side required, round off and provide more. If this step is not clear, you should not go to structural engineering design. Remember, over. Now, but we are discussing rectangular. Actually, rectangular only, square is included. Okay, now, how you decide L1 and L2? But remember, there, how to decide L1, L2 when there is no restriction for L1 and L2. Very, very important. Now write note here. Now, further steps I am going to give is, you should write. If you want to learn, you should listen to what I am telling and write everything. Not simply listen once. Later, sir, other case, I told you on that day, why you are not written? Sir, martoitu. I thought it is clear to me. It is clear to you at that time. Now it is not clear. Further explanation is when there is no restriction on L1 and L2. Make a note. Sometimes in building cases, due to overlapping one of the side, there is restriction. Then it is not called good footing, it is called bad footing. I will tell that also here because E-tap safe required. So bad footing because not that way bad. It becomes uneconomical. So when there is no restriction, see, in a building hall, sometimes space will be there. Sometimes because of the property problem or when columns are very closer. If columns are very closer, you can go to combined footing or you can go to what? Raft footing. See, lift 4 columns are there, close by. Go to raft footing. But under a normal case, imagine space is there. Then what to do is, you decide L1, one more thing. Suppose due to some reason, there is a limit for L1. Then once, that means you know how much L1 is allowed. Then, even then you come here, who knows, that much L1 may not be required. Imagine 3.5 meter is possible. You should not go beyond 3.5. But if you manage for only 2.5 meter, don't waste. So later I will tell you, when you go in the Excel sheet, then I will tell you that one. See now, L1, L2 over. Now, how to fix L1, L2? See now, when you consider the footing slab later, I am showing you something, you make a note. He stopped the class, he right here, he placed the pen somewhere there, immediately searched for a book, something like a book here. He used in the hand and placed the column load. See, they will be bending and shear. See now, clear? Bending is this way and also this way. See now, this is the effect. Therefore, for cross section of the slab in both direction, there will be bending moment and shearing force. And common sense, tell me, the bending will become more when projection is more or lesser. Tell the answer. The bending will become more and more if the projection beyond the column is more or lesser. Common sense. The bending will become, bending and shear will increase if the projection beyond the column face is more or lesser. Is more. Therefore, what you have to do is, suppose you provide the footing slab, see, for example, suppose you provide the footing slab something like this. This all you are right. Suppose you provide footing slab like this and put the column this way, then see here. Here lesser projection, here higher projection. It will have very heavy bending, this lengthwise. Widthwise, lesser bending and shear. Heavy bending and shear, lengthwise, and widthwise, lesser. Now, what you can do is, you can reduce this length and increase here, if it is allowed. See, by doing that way, see, earlier, lengthwise bending shear effect is 100. Widthwise is only 50. Now, by providing this way, the 100 can be reduced to, say, 75. Then 50 will increase to 70. Oh, good. Why? Earlier your critical came 100, now reduced. Or one particular value, this will come 71.8. This also will come 71.8, almost equal. So, when either side bending and shear, they are almost equal, that is called most economical. Therefore, for the most economical design, tell what you want. The projection of the footing beyond the column, both lengthwise and widthwise. For most economical design, that is what majority are doing. Some people, I have seen some foolish statement, I don't want to tell the name. Somebody has told, you provide L1, L2 in proportion to S1, S2. 100% nonsense. I don't know why he wrote it, who I am not telling. That is utter nonsense. You don't provide L1, L2 in proportion to S1, S2. If you provide that way, architect will throw it outside. He sometimes, for a column of 200 by 500, 1000, your foundation will be 6 meter by 1.5 meter. He will tell, loser, etarna. He will tell that way. No. That statement, first of all, I won't name who has given. I saw in a book only. Provide L1, L2 in proportion to S1, S2. Complete nonsense. So, you provide L1, L2 so that projection of the footing slab beyond the column face, both lengthwise and widthwise. See, now onwards, I am using one word. This way, see the plan. This way, I call lengthwise. This way I call widthwise. LWB, see, I will write lengthwise bending, LWB, WWB. Don't tell WWS or LBW. This is like LBW. No. When I put LW means lengthwise. If I write LWB means lengthwise bending. If I write WW means widthwise. If I put WWB means widthwise bending. Clear now? Short form to save time. Short form to save time. One is lengthwise bending, etc. Other is widthwise bending. Clear? Clear or not? I will use these words. Okay. Now, so you provide L1, L2 so that projection lengthwise and widthwise are almost equal. See, are almost equal. Exact equal not required. Almost equal. Almost equal. So then the critical bending moment and shear force will drastically reduce. It will come the minimum possible. Most economical design. Or remember, fix L1, L2 so that projections are equal. This is already explained in RCC class thoroughly. So further I need not tell, sufficient. So on that basis, you get a second equation connecting L1 and L2, right? You get a second equation connecting L1 and L2, solve, get L1, L2 and provide and proceed further. Okay. Now, I will give an example for you. One example I will give you to get L1, L2 first. 1 minute, I rub this one. The cloth is black, not dirty cloth actually, because of cleaning of the ink. It is a very clean cloth because of repeatedly using for board washing. Okay, now I will go for example. What I will do is, I will give an example first. 1 minute now. Instead of wasting time for example, I will go to the real example. See, if you remember, those who are in RCC batch, I explained for axial load with BM. Only axial load. I told them I will write and give you. No, now I decided anyway doing here. See, therefore, see now, what I will do is, instead of telling non-stop theory, I will start the first example. Whenever I need explanation, I will tell the example, you wait. So what you should do is, what all extra I am telling, you should write separately. Problem, you should make what? Compact one. See, I will write a question here. See, I will put a question. First, remember, this question will give complete clarity for design of footing for axial load. And one more thing, when you design practically for axial load and with the biaxial bending moment, then procedure is same. 95% of the principle is same. What you are using here, some extra. So this is very powerful question. Remember, see, a column, I put question here now. Design the footing. See, now you should do one thing. Problem part you write separately. Don't continue. Because I am giving some explanation here. You first finish all the explanation. Once I finish everything, then write, go through the class once again. When I write, whatever I tell for the problem, write in the problem part. Whatever I explain here, write in the explanation part. Design the footing for a column. I am rubbing this one. I want space later. For a column, see, I will go for column dimension 230 millimeter, 9 inches. Because I want fractional values. 230 mm by 550 mm. I want fractional value deliberately, mm. For given data, following data. For following data. Following data. First, axial load. Axial load equal to, I should give such axial load that that column can take it. Because otherwise someone will ask, 230 by 550, that much axial load is giving. 101 divided by 1.5. Okay. Axial load is 850 kilonewton. Okay, done. Only axial load. Then SBC of soil data. This is from soil testing. SBC of soil is 175 kilonewton per meter square. Then concrete to be used, M20, M25. Okay, I use M25 concrete. Steel, tar up grade FE 500. This is what I am going to use. Popular one. Nowadays, more and more people use FE 500. Okay. This is the foot. That's all. Design the footing for the column. See now, I am starting solution here. See correctly. If you want, I will do one thing. As I start solving, I will dictate the steps for you. After the class is over, separately you write the steps. Understood? Tell me. I will dictate the steps here so that you take separate paper and write what all steps I tell. Clear or not? Separately write the steps and learn everything. Get a solid structural knowledge. Okay, see, first step. And remember, 850 kilonewton load, first make a note. You should consider the working load. Therefore, in this question, he told 850 kilonewton, that is actually understood working load. Therefore, thank you. In case somebody gives you factored load, you should get working load, not by multiplying. What do you have to tell me? In case someone will tell factored column load is 1500 kilonewton, then what do you have to do? Don't multiply. What do you have to do? Tell me. In case top portion not visible, where? Why? It is visible, I think. Visible. Fully visible. How? Fully visible. I can see here. Tell me what you have to do. In case by chance somebody gives you factored load, what do you have to do? You want working load. Don't multiply. What do you have to do? Divide. That much common sense required. Okay, now see, first step. First find area required in plan. In plan for footing. For footing. Equal to 1.1 P divided by SBC of soil. Remember, same steps are going to be used for Excel sheet also. Anyway, Excel sheet I will give in the class. Okay, equal to, substitute, equal to, in the bracket write, assuming, so that perfect solution, assuming weight of footing and any other extra weight as 10% of column load. Of column load, that is P. P. Substitute, right, substitute 1.1 into column load P, 850 kilonewton working load by SBC is 175. See, this is in kilonewton, this is in kilonewton per meter square. Area will come in meter square. That much common sense should be there. Answer first. Don't go to Newton. When you do pressure, it is always kilonewton and meter. When you go to bending moment shear post later for design RCC part, then you go to Newton millimeter. Answer fast. Don't waste time. 5.343 meter square. 5.343 meter square. Right. Whatever area you are going to get, remember right there, equate it to L1 by L2. That is, you write a note there. That is our footing plan of the footing. Our plan of the footing is something like this. This way. See, this is your L1, this is your L2, and somewhere here column is there, placed centrally. One side is S1, one side is S2. Column load is here P dot, equate to L1, L2. Call this as equation number 1. Okay, now write next statement. To decide L1 and L2. L1 and L2. Right story. L1 and L2 are decided so that, I will tell only one, so that projection of footing slab beyond face of column, projections, not projection, projections, plural, bahuvachana, of footing slab beyond face of column are, see, almost equal, exact not required, almost equal in both directions. In both directions means lengthwise and widthwise. Length, that is, you are making lengthwise projection almost equal to widthwise projection, right? Now, lengthwise projection, LWP, no LWP equal to L1 minus S1, see, I am using red color, very important, divide by 2, and widthwise projection equal to L2 minus S2 divided by 2. See, lengthwise projection means, you want, see this one, these two are your lengthwise projection and these two are your widthwise projection. Therefore, lengthwise projection equal to L1 minus S1 divided by 2, and right, for our column, now come to question, for the present example, column you can place whatever way you want, no restriction. I will place the column like this. No, so that way means turn the paper. You never bother S1 more. You place the column. I will place 550 mm this way and 230 mm this way. No, sir, it is other way. You see from that side. That is not a problem. So we will place the column like this. If it is other way, turn the paper. Instead of seeing from here, see from that side. Okay. Now, therefore, for our example, this is not in the procedure sheet. In the procedure you should write substitute and equate. Get equation number 2. Then solve 1 and 2 and get the answer. For our example, see, lengthwise projection equal to, how much, tell me? L1 is unknown. L1 minus, tell me answer. This is your S1, this is S2. Tell me, how much S1? Fast, answer. L1 minus S1, how much? Part S1. Part S1. Ayyo, if you substitute 550, it will become half kilometer length of the column. Imagine, your area is in meter square. So, you should be careful. This is the minimum requirement. See, first of all, these things should not be told for someone who is studying structural engineering for practical design. If such mistakes are made, it becomes completely nonsense. Tell how much I have substitute now. I can't substitute 550. If I substitute 550, means your column is half kilometer. I had substitute 0.55. See, L1 minus 0.55 divided by 2 is lengthwise projection, and our widthwise projection is L2 minus S2. How much S2? Tell me. How much S2? S2 equal to, here, our question, 0.23 divided by 2. Therefore, right here, for this is not in the procedure sheet, problem. Lengthwise projection, for lengthwise projection almost equal to widthwise projection, what you get? You get L1 minus 0.55 divided by 2 should be almost equal to L2 minus 0.23 divided by 2. This is your equation number 2. This is your equation number 1. That is equation number 2. Now, solving 1 and 2, tell me the value of L1 and L2. Okay. I talked for non-stop 1 hour 15 minutes. Therefore, when you solve this one, I'll take 5 minutes break. Okay, start. You take a paper, write, and get the values fast. Solving, get L1, L2. That much work for you. See, solving. Don't tell us immediately now, because why? I told break means I have to. Oh, my where? See, I will make this design part of footing perfectly covered. Don't worry. Each and every principle will be told. Like one-way shear, wide that is punching shear, how punching shear area comes, one-way shear is what, how bending will come, how the steel provided, everything, including development length also, if requirement is there. That is perfect knowledge for footing design, so that when you design by Excel, you should be, not Excel, when you go for E-tab and shape, you should have full control. Stop, fast, just 5 minutes, I'll continue. Get the value of L1, L2. Time is there. Today class up to 9:30, not 9 o'clock. Today Saturday, so class up to 9:30. Remember, so time is there. Ready? I will continue now. Some answer came. Actually, I should need not explain. Still, I will tell because for Excel sake, you should know how to program in the Excel sheet. That's why I will write little more for this one. See, now this much we got. How to solve? This I will remove now. See, I will remove the question now. I may ask you later. 850. You should tell this answer. M25. I write here so that M25, FE 500, SPC is 175, and column load I won't forget. Column side I won't forget. Okay. Now this I will remove. See, how to solve means, see, you should not stop here. You have to continue. Directly solving not possible, not a big one. See, actually what you do is, don't write this as 2. You continue this one, continue. See, 2 will cancel, or rearranging, what you get? Rearranging L1, take other side, minus L2, minus 0.55 plus 0.23, this side is 0.22, correct? Minus L2 minus 0.22 equal to 0, correct? You make this as equation number 2. This is equation number 2. L1 minus L2 minus 0.22 equal to 2. Now do one thing. From 1, L1 into L2 is almost equal to 5.343. You replace one of them in terms of other one. I want L2. So therefore, you can change your L2 equal to 5.343 divided by L1. And now substitute in 2. What you get? L1, write L1 minus L2, 5.343 by L1 minus 0.22 equal to 0. Multiply throughout by L1. What do you get? You get L1 square, then write this one first, minus 0.22 L1 minus 5.343 equal to 0. Quadratic equation solve, you get the L1 value. Someone told L1 he is getting how much answer? Oh, here. Someone told there L1 comes 2.477. Is it correct? Tell the answer. I do not want to make mistake here because this class will be there in the YouTube permanently. So tomorrow I do not want some people who only want to find mistake in calculation. Such people, they are actually insult to education. Trying to find mistake in the calculation, that is called insult to education. Because I have not calculated. You told, I wrote. So preferably see that mistakes are avoided. Correct answer? Okay, someone told, I got the same value. I will continue now. Okay. 0.32. Oh, sorry. See, 22, 32, 42, 52. Oh, this is point, how much? This is point, this is point, where is it? 0.32. Okay. See, anyway, answer is correct. Tell the answer. L1 is 2.477. Is correct? Tell me that one. L1, how much you told? L1 equal, correct? Okay. L1 we got how much? 2.477. Then substituting L2 equal to how much? 5.343 divided by 2.477 equal to 2. How much answer? 2.157 meter. 2.157 meter. So therefore, write a note here. When I go to Excel, I will tell how to solve this one. So make a small note. What note? Therefore, for only axial load, L1 required is how much? 2.477 meter, and L2 required is 2.157 meter. Okay, now This is the requirement. You should provide area, at least how much area comes here. If you multiply this one, your area will be 5.343, for which pressure will be exactly equal to SBC equal to 175. Now, round off. Let us take, now, round off. See, 2.477, round off. See how much? Round off, not too much round off. Slightly round off. Don't waste. Tell the answer. 2 point multiple of 0.05 I will do. That's all. I will round off to multiple of 0.05. How much I will take? I will take L1. Take L1 equal to 2.5 meter and L2 equal to 2.157. Actually, if you make 2.154, you can make 2.1 also. A little freedom. 2.15 is 2.2 meter. We are providing L1, L2, this one slightly more. Now, one condition. There should be a space for L1 of 2.5 meter. Width-wise, there should be a space of 2.2 meter. It should not cross the boundary line for the end portion or should not overlap on other footing for other columns. That you have to verify. If it is not satisfied, what to do? Not in this course. Not in YouTube course. What to do? Suppose, imagine, available space for L1 is only 2 meters. Possible. Why? Other footings are there. Then what to do? I will tell in E-tab and safe batch later when you go to building design. Right now, those things all I can't cover. Actually, remember, in most of the building, there will be no problem. If problem comes, how to overcome, that will be in our main course. Everything I can't tell here. There is a limit. If I keep on telling that way each and every one, this foundation for axial load, next axial load with the M1 and M2 will take 1 month then. No, I can't afford that much. Okay, now, so this is L1 and 2. See now, what I am going to do is, this question I am completely solving. Tomorrow will be fully over. You require punching shear, wide beam shear, reinforcement. Tomorrow long class is there. And one more thing. Tomorrow's class, what I will do is, I will send you 2 links, not 1 link. 2 links. First link starting at 5 p.m. Second link starting at, not 2 links, I will give you 3 links. First link for starting at 5 p.m. Second link for starting at 7 p.m. Next link starting at around 8:30 p.m. Or 5 means 6:30 p.m. and 8 p.m. Why? If something goes wrong, lot of time is wasted. So what I can do is, suddenly go there, cancel this one, activate that one, start. Within 1 minute I can do it. So that I will send the pre-link tomorrow because 4.5 hour class is there. And if something goes wrong there here, if further something goes wrong, I will prepare. Or by chance, after taking for around 2 hours non-stop, if I feel I need 10-15 minutes break, then I will do one thing, log out. Click the second link. I will start. If I write 6:30, there is no rule in YouTube that you should start at 6:30. It is a tentative time. So I can schedule a program tomorrow and start right now. Or prepare a program for tomorrow and start next year also. It will be there. But notification will go for 6:30. That's all. In the class I will tell. Now click this one. See, this I will tell class number. Today's class I forgot now. I think 28 I think. This I will write 28 extended. This I will write 28 further extended. So clear now? So I will, long classes, I will prepare 3 links. Because otherwise why? That thumbnail portion, title I write, all I will prepare so that all I have to do is some problem. Cancel this one, go and click that one, that will come live. Clear? Only for long classes. Even for short class also, from today I will do one thing. I will have a parallel class, parallel link there so that if something goes wrong, any reason, then I can go to the parallel one. Okay, now 2.5 meters. Okay, start. Now, next step, write theory portion, steps. Solving 1 and 2, get L1, L2 required, and then round off and little liberally provide. Okay, now, Next find, I am telling steps here and also numerical. What I tell steps you should write in the procedure sheet. Next find, actual area provided. What is the actual area? Area means in plan. Area provided. Actual area provided equal to L1 into L2 finally provided values. Yeah, there that's all. In the theory sheet you write, find provided area L1 into L2. Now, in the problem, it is 2.5 into 2.2. Tell the answer. How much area is actually provided? See, required area is 5.343, but provided is slightly more. How much? Slightly more is there. Exact 5.5, huh? Exact 5.5 it is. Oh, exact ಬರೋದಿಲ್ಲ ಅವಳು 2.5. Okay, thank you. Is okay. 5.5 meter square. Why you require? Because therefore find now very important. You should write a note or I'll put red color. Very important note. You should write if you want to learn. Once you provide L1, L2, you should ensure that pressure does not exceed SBC. If it is pure axial load, waste of time. Tell why. If it is pure axial load, it is waste of time. Why? Reason. Because for controlling the pressure, you need area of 5.343. Therefore, for this question, actual gross pressure, which is uniform. Why uniform? Because axial load equal to 1.1 P divided by area provided. It is a waste of time doing, because why reason? Because 1.y into ಎಷ್ಟು load ಅದು? ಅಯ್ಯೋ, that load only forgotten. Where is that load? Who knows that load? Tell what is the load given? Forgotten. See, this way if I forget problem. What is the axial load given? 750 or 800, something like that. Axial load provided. Okay, Vande Mataram. Someone told Vande Mataram. 850. 1.1 into 850 divided by area provided is 5.5. Tell me what is the actual gross area, actual gross pressure in Kn per meter square. I will tell you. It will not come 175. It will come slightly lesser. Why? 170 Kn per meter square. It is 170 Kn per meter square. It is less than SBC of soil of 175. Therefore, okay. Remember, someone will comment who knows subject. This person does not know anything. He calculated area provided to control the pressure to 175, only axial load, and once you provide the area, he rounded both the sides for higher side and he gave little more area, and then again he is checking foolishly the pressure he got 170 less than SBC, safe. For him I will tell, this is I told in the class not required, but it is required. Tell when? Remember, later when you go to design of footing for PM1, M2, when you go for practical design, each and every problem will have PM1, M2. This question is only for understanding. Practically, only axial load will not come. Therefore, there we are going for approximation. What area you require, you magnify the area accounting for pressure. Therefore, there, after you decide L1, L2, you have to find maximum pressure and ensure that it is within SBC. If unsafe, you have to redesign. Therefore, keeping in mind the future, I wrote this step. This is not required because when requirement is exactly 5.343, it is exact requirement. And provided 5.5, I am not that much fool to go for a check for pressure. So I told this one only for future where the requirement is approximate. Therefore, when approximation is there, you have to go for rigorous check. For that purpose, I am telling. If at all somebody comments, I will tell him first, come to me. Don't comment. Come and talk with me. Okay, now most important, write a big note in both theory and problem. Note, pressure check over. Thus, L1 and L2 provided are okay to control the pressure. To control the pressure, and remember, controlling the pressure means always based on gross pressure. Gross pressure. Okay, now the most important. Now means ega, not Telugu movie ega. Now we are entering RCC part. RCC part means what? MU, VU, FCK, FY, XU, this one, that one, MU limit, AST, etc., etc. Therefore, when you enter there, or you can write, we are going to decide the thickness of the footing slab and also reinforcement. We are going further to decide thickness of footing slab and also reinforcement. That is based on RCC equation. At that time, or for that, we have to consider, tell me, what pressure? I told you very clearly in the RCC class with the reason for you. In the original RCC batch, I told crystal clear reason and proof. Others, you have to believe me. If I explain that one, it will take half an hour. No, for a software course, that side explanation I cannot give. There's a limit. Tell what pressure you require now. Now tell me, what pressure you require now? Not gross pressure. For any continuation now, we need what pressure? I told earlier. We need net pressure. Net pressure. It has got a beautiful reason. Someone, I don't want to tell, teaching in a college, he told me actually, sir, there's a problem for me. What? Foundation, sometime in the beginning you take gross pressure, then you go to net pressure. Somebody asked me why. What you told? I told him, no, these are not required for you, traditionally done that way. And then I laughed only. Why? Then he asked me, actually I was going to that college. Then he asked me, please tell the answer. Then I told him the reason. He told, oh, so simple. Yes, you would have told. It never occurred to me. He told, it never came to my mind. I thought it is a universal procedure. It is not a procedure. It has got reason. So right, now you need net pressure. When you find net pressure, only P considered. Only P. That 10% more is not considered. Make a big note. When you find net pressure, 10% more is not considered. But ETAB and SAFE will consider, still not consider. They will consider it and cancel it. I will show you in the SAFE model. When I go to SAFE model later, I will show you. See now, long back I told, see, it considered the 1.1p, but actually not 1.1p. In SAFE, it knows the weight of footing. Why? Because you are giving footing dimensions there. It knows it. So it considers self-weight. Later, you can see it, it subtracts it. It will subtract. Anyway, my duty to explain these concepts is only for pure RCC batch. Pure RCC batch, I thoroughly explain. That's all. Others, every other, what I am doing is a bonus. Remember, first of all these explanations are bonus. Therefore, next step is calculate net pressure. Since load is only axial, you write net upward pressure. Net upward pressure. Net upward pressure equal to P by A. That's all. P by area provided. P means column load. Net upward pressure. My symbol is W, I think I take a symbol there. Okay, I'll take WP, upward pressure. It will be force per unit area equal to 750 kilonewton divided by actual area provided. How much you told just now? Actual area provided. How much you told just now? Oh, not 750, 850. Okay. 850 is in kilonewton. Actual area provided. How much you told just now? 5.5. Tell the answer. Therefore, Wn means net upward pressure, and it is uniform. Today it is uniform. When you go for design of column with axial load and bending, it is not uniform. It is varying. We will take linear variation, but practically SAFE will not take. You have to give soil subgrade reaction. It will take that parabolic and higher order variation. Error is not much. Manual design, we take linear. Why? P by A plus M by Z means bending equation. We take linear, but software will consider settlement also. Since it considers settlement, pressure will not be linear. Error is very small. Answer 154.5455. Shall I write 55 only? Sufficient. Children bada bidi. Parvail, okay. I will write 154, okay, 0.545. 545. This I require tomorrow also. I will write here. 154.545. Otherwise, you will not. Load is 850. Okay. 545 kilonewton per meter square. Remember, this is the upward pressure on footing slab from the soil, or upward or downward pressure on soil from the footing, action or reaction, upward pressure on the footing slab from soil. See, it is like this. For footing, downward pressure. For downward action. For footing slab, upward pressure from the soil per unit area, Kn per meter square. Remember, it is per meter square. Up to here, fully clear, fast. Up to here, tell me, fully clear or not? Fast I want. I will continue further. Little time is there. Up to here, fully clear? Okay, now write design principle. Now go to design principle of footing slab. Design principle for footing slab. Footing slab. Footing slab. What you have to do is, see now, first, footing slab, I will write here. I will not, this you have to write in the theory sheet and also write in the problem. See, you write about footing slab is designed for bending and shear, considering projection of footing slab, beyond the face of the column, anybody can tell as what? Projection of footing slab. See, once you understand this design and later understand P with the M1, M2 design, you will become master in design of isolated footing. Permanent control is there. You should know that much. Once in a time you get such chances. Textbooks all you won't get this information. Or go to other online classes, they will tell, but no one will tell this much split by split. By this time, see 35 minutes video, that I will call video. I have seen a class, 25 minutes, 30 minutes video, they finished complete footing design. Over. They will keep on telling something. As what? Considering the projection of footing slab beyond the face of column as what? First. You know it actually. I am asking because why? So many of you came to my earlier class as, correct, cantilever, as as cantilever, as, I wrote here, as cantilever, comma, fixed where? Tell me. Fixed where? When you take a cantilever, one side is fixed, one side is free. Fixed where? At the face of the column or edges. Where fixed? Fixed at where? Face of the column or edges. Fixed at fixed at the face of the column. At face of the column. Face of the column. Okay. Comments by a new person. See, so far no comment. Suddenly today comment started. Okay, good. At least comment, whoever it is, you give the comment so that gives confidence, not only to you, to me also. Okay. Further, fixed at the face of the column. Okay. Now, remember now, and also subjected to what? Upward pressure. Upward pressure, that is nothing but net pressure. WP equal to 154.545 kilonewton per meter square is the principle. In the procedure sheet, you should write subjected to WP. Okay, now, further note. This I will remove now. Further note. Correctly understand how is the cantilever. I will correctly explain today. Then I will go to next step. I will continue later. Okay, see now. To understand correctly, you put the plan. This is the plan. See, these are all should come to natural to the mind. See, when you tell a foot, if suppose I get a phone call, someone will ask me, upward pressure so and so, I want check for shear, this much steel is there, that's all. To the mind, what will come to me? I can see a footing slab, I can see the pressure there, I can see diagonal tension crack, I can see a critical section. It should be visible, not only numerical. See, this is your L1. See now, L1 equal to, forgot now, 2.5 I think, correct. 2.5 meter. I will write here, space problem. This is your L2 equal 2.2 meter, 1 minute. Board visible fully? Visible, okay. Then your column is here. This is the column. It's a column. Now, this column side is 0.23. This column side is 0.55 meter. Okay, now this is a column. Now see, correctly calculate. 1 minute now. I'll do one thing now. Column load is acting this way. If I take a section here, see, section 1, what you can see? You can see the column here. Column here. You can see footing here. One thing I forgot. If pedestal is given, what to do? I will tell later. If pedestal is given, then you should consider pedestal here, not column. Whatever is in contact with footing, that becomes column. This is a footing. Okay, now see. Your column load is acting like this, P. And because of the P, there is upward pressure here. UDL. This is your WP sufficient equal to 154.45 154.545 kN per meter square. And remember now your cantilever is, see, this way, again UDL here, so this will bend like this, this will bend like this. Therefore, your tension will be in the bottom tension. So, this is your steel reinforcement, or this is your lengthwise steel, LWS. Board fully visible? Okay. This is your lengthwise steel, AST. Lengthwise steel means AST. Okay. And if I cut here and look from this side, I will write this way. You can see column like this, look from this side. Footing here, this should be completely clear now. No doubt, nothing. Yeah, so column right. Okay. This way, out of scale, no problem. Don't bother about scales or sir, it doesn't look equal. Leave it. Those comment on those things. This is the column load, not horizontal, vertical. I am seeing here and turning. And this is the pressure. That is once again WP equal to 150. At the end of the class, this will be by-hearted by me. 545 kN per meter square, and we are considering this as a cantilever. We are considering this as a cantilever subjected to upward load, because view here, or this will bend like this, this will bend like this, or tension comes here, tension comes here. This is your width-wise steel. Length-wise steel means AST. This is your width-wise AST. And now do one thing. Calculate actual projections. Actual projections. Because they are not exactly equal. Right. Actual lengthwise projection equal to 2.5 minus 0.55 divided by 2. Tell the answer. 2.5 minus 0.55 by 2 is the actual lengthwise projection. Answer. Give the full number. Don't round off. Give full number. Don't round off. Give the full number. Don't round off. Actual lengthwise projection. Theory you have to write. Once all the story is over, you write actual projection 0.975 meter. 975 meter. Go back and enter to understand. Go back and enter. See, this is 0.975 meter calculated value. Enter here also 0.975 meter. Rounded means what? Calculated. And calculate actual width-wise projection equal to 2.2 minus 0.23 by 2. It will be almost equal. Slight change will be there. No problem. How much? Width-wise projection. It is not 0.575. It will change. We need exact value. But in the shape and E tab, it will calculate. You don't have to bother. 0.985 meter. Right. 0.985 meter. Right. Go back and enter. This is 0.985 meter. This also is 0.985 meter. Okay, over. Now, already over. Tomorrow, when you come to the class, this sketch will be there as it is. Because why? I don't have any class. Tomorrow is the longest class for you. Tomorrow, class will be there. This sketch will be ready here. I will remove this one all. This sketch I will not remove. And I will tell you how to find bending moment, how to fix the depth, how to increase the depth based on shear, then how to check for punching shear, how to find steel for bending moment, then how to perform that check for one-way shear, and finally make foundation shape. All will be covered tomorrow. So far everything told today, fully clear? See, and one more thing. Tomorrow's class in the beginning I will tell, those who are absent yesterday and has not gone through, leave my class. This class is not for you. I am continuing only for those who are serious and who came to previous class. See, one more thing. This is out of scale. See, this is small. Ayo, no problem. 0.2. See, this is your 0.23. Little out of scale. This is 0.55. Okay, no problem. I will tell, go through, or you should study thoroughly and continue. These two values I will not explain tomorrow. I will continue further. As usual, once I will keep on telling you procedure, write it and complete the question. Then I will go for axial load with M1, M2 both. Remember, this class I will continue full in the YouTube. Today response is little better than last time, I feel. See, at least there are some people more. You should come more number. I told you, parcel service is not there. If you want to get what I am offering here, if you want to utilize it here, you should participate more. If I still feel after this question completely over, no, response is not good, or everybody want parcel, then I will once again go back to my Zoom only and continue there that important question. Which one? Axial load and M1, M2. I will not continue YouTube. I will not tell anything. I will not tell anything. I will silently send the link in the Zoom and continue there. RCC people and ETAP people will get it. Others won't get it. I told, parcel I don't like. Don't ask for parcel when you go to free food. Footing size parallel to is 0.55. DIMS is 2.5. 2.5 ಏನದು? Footing size parallel to 0.55 is 2.5 ಅದು? It's 2.5, correct. What is problem? 2.5, correct. What is, oh, you are telling the answer to me. Any problem here? 2.5 is correct, I think. Other is 2.2. Any mistake? Tell me fast. Any mistake so far? So, see, sometimes by mistake, if a dimension is missing, it is called print mistake in my class. It is not technical mistake. Everything okay? No, any problem? Someone just now commented, footing size parallel to 0.55 is 2.5 meter. 0.55 is 2.5 meter, correct? See, I am projecting only 2.5. Footing size parallel to 0.23 is 2.2. What is wrong? No, when you put a comment unnecessarily, I start wondering, what is wrong? I did not ask the question. I don't know, maybe, I don't know what is the reason for that comment. Footing size parallel to 0.5 is 2.5 meter, correct? Parallel to 0.55 is 2.5 meter. Parallel to 0.23 is 2.2 meter. Then what is wrong? Then what is wrong? Why that comment came? There should be a reason for the comment. Okay, comment cancelled. Why? You tell, okay, no problem. You should put in between when I am telling something else. For any previous value, if comment is there, you should tell entry is wrong. Okay, leave it. Okay. Tomorrow I will continue from here only. Thank you. We will meet tomorrow. Go through today's class again and again and learn thoroughly. Come fully prepared tomorrow. Okay. Yes, I am going to close now. Over. You can log out.